In today's video, you're going to be solving exponential equations, okay? What you have to find is what the x is. You have 5 to the x power equals 125. You're going to put x equals. Now, you want to make a caret symbol because that means 5 to the power of x. That stands for its power. So the x I'm solving for is part of the power. I would just recommend you put that when you solve these equations where the variable is a power. So what you want to do is put the base and the exponent in parentheses, okay? Now, make sure you don't have any operations outside the base power combination. You don't. So then what you're going to do is you're going to circle what the power is and set it equal to the log over the log. So your base is 5. Remember, you always got to put the base on bottom. The exponent's base goes on bottom, the 5, and then up here is the product, which is 625, whatever it comes out to. Now you go to your calculator. So you take log 625 divided by log. Remember to close the parentheses before you hit divided by. And you come up with 4. Okay? And that makes sense because 5 to the 4th power is 625. If you take 4 5s and multiply them together, that's 625. That's why it's 4. Okay, next problem. 25 to the power of 2. If you see the variable you're solving for, if you see it to the top right, it's a power. Okay? So if that variable is a power, your first move is to parenthesize the base and the whole power. Any exponents outside, or excuse me, any operations outside? Nope, there's not. Like operations outside, I mean, is there a number that's times in the front of the parentheses? No. Is there a number that's added behind the parentheses? No. So you circle your power, 2x this time, and then you set up your log ratio. It's called the change of base. Okay, you go right to your change of base formula. It's called COB, change of base. So 25 in the denominator, that has to go here, 125 in the numerator. So you take log 125 divided by the log of 25 and you get 1.5. Then I divide both sides of my equation by 2. Then 1.5 divided by 2 is 0.75. Solved. Now, before I forget, can you please go to number 12 on the assignment? There was a number 12, I want an 8 there, not a 54, okay? I want an 8 there. Okay, anyway, back to the examples. So 3 to the power of x equals 36. So you're solving for x, and the x is a power, okay? So first thing you want to do is parenthesize the base and its exponent. Make sure there are no operations outside. There are not, so I circle that exponent and use my change of base, COB. So that exponent x is equal to the log divided by the log, and you got to do this right. You put your base 3 on bottom, you put 36 on top. So then you take log of 36 divided by log 3. Pretty cookie cutter process, 3.26. There's your solution. Okay, 7 to the power of x minus 3 equals 25. 7 to the x minus 3 power equals 25. So you're solving for x, and the variable I'm solving for is within a power. Okay, so parenthesize the base and the whole exponent. Now, you're like, do I have to block off that minus 3? And the answer is no, okay? No, you don't, because you're not graphing, okay? You cut that off on a graph. That's not what we're doing. We're trying to solve for the x. So, nothing going on outside, so I circle the exponent. This time it's, and apply my change of base. So the exponent this time is the expression x minus 3. So I set it equal to the log divided by the log. So the base 7's on bottom and then 25's on top. So then I take the log of 25 divided by the log of 7, and I get 1.65, but to actually solve for x now we have to add the 3, and that's 4.65. Pretty much the same process throughout there. Now on the back side, game's going to change a little bit. 5 to the x power, and then plus 3 equals 12. So we're solving for x, and x is a power. So if the variable I'm solving for is a power, we want to parenthesize the base in its exponent. The plus 3 is not an exponent. Now, do we have an operation outside this time? And the answer is yes, we have a plus 3, so we have to minus 3 first. Because I have to find out what 5 to the x power equals. It'd be 9. Keep that parentheses there. Now I don't have any operations, so I take that and apply the COB, the change of base formula. So x equals log divided by log, and your base of 5 on bottom, and then the 9 product goes on top. It's got to be that way. You can't get them backwards, okay? The base always goes on bottom. That finds out how many 5s it takes to multiply to 9, okay? Well, it's going to be between 1 and 2. It's going to be an irrational answer, and that's fine. So I got 1.37, and we're done, okay? So that's an approximation, not exact. 2 times 10 to the 2x plus 1 power equals 30. So you're solving for x, and again, the x is within the power. Okay, so this is the procedure. You have the base is 10. You can't take 2 times 10. I'm just telling you that now. See, the 10 has this exponent, the 2 does not. So they cannot; those factors cannot be multiplied, okay? Stick to the plan. You're parenthesizing the base and the exponent, okay? Now you do have an operation outside. You have a times 2, so you need to be dividing by 2 to get rid of the times 2. So that takes us to 15, and then I have my 10 to the 2x plus 1 power. Now we're good for the COB. So in change of base formula, you circle the entire exponent, 2x plus 1, and you set that equal to your log over your log. Okay, so 10 is on bottom, 15 is on top. Now I'm going to calculate the log over log. I'm going to have to minus 1 then and divide by 2. And I get 1.18. Minus 1, that takes you to 0.18. Then you divide by 2, and that takes you to 0.09. Some of these answers look a little sketchy, but they're right. Okay, next one. 5 times 3 to the 2x minus 3 power equals 500. So you're solving for x, and again, x is in a power. It's an x power. So you're going to have to use first, so you parenthesize the base and the power. Okay. You make sure all up, get rid of that times 5. So you divide by 5 to get rid of a times 5. I mean, the dot's right there to tell you what operation you're trying to get rid of, and that would be equal to 100. And then I've still got 3 to the 2x minus 3 power. Now I go to my COB formula. Okay. So I circle the power, because I know that that expression 2x minus 3 equals log. So 3 on bottom, 100 on top. Okay, 4.19. And then you need to add the 3 and divide by 2. So that's going to be 7.19. Divide each side by 2. And I get 3.60. Okay, 10 times 4 to the power of x equals 1,000. So again, just like on all the others, we're solving for x. X is in a power, okay, within a power. So I parenthesize, don't take 10 times 4. You can't do that. The 4 is to the power of x. 10 ain't to the, it's to the power of 1, but if the powers don't match, you can't multiply them. Okay? So base is 4, exponent's x. Before you even do the COB, though, you got to get rid of your times 10. Okay? You're going to get rid of that by dividing each side by 10. So that's going to be a 100. Now I can take that exponent and use my change of base formula. That will tell me what power the 4 is taken to approximately to get to 100. So x equals log, and you take your base 4 and then 100. So I take log 100 divided by the log of 4. Okay, 3.32. That's all she wrote. Now, if you want to pause this video right now, you should be able to complete 1 through 8 pretty easily. I don't think there's any operations on any of those problems that you would have to deal with. Okay. Now, I'm going to set up number 4 for you, please. I'm going to set up number 4. So again, you're solving for x. That's within a power. So parenthesize the base and exponent. You don't have any operations outside, so you go right to the COB. So you take the expression 3x, and when you do your log, you don't fret the fraction. You put the base 5 on bottom and then 1/125th on top. Okay? It will work. Just ABC it, just like I did with the 1/25, then close the parentheses, just like you see. Okay, 1 through 8. Okay, here's the next part of the assignment. Now you're solving equations that are in log form. You got to get rid of that stupid logarithm. Okay, remember a log needs a base first, and if you don't see a base, it's going to be a base 10. You're going to put a 10. Now you're going to write this so it doesn't have the log. You're going to put it into an exponent form. Now, here, remember how this works. 10 is the base. What it's equal to is your power. Okay? So set up a base 10 to the -2 power. And over here you have the expression 5x. Okay? Now you're solving for x, but x is not in a power. See, the power is here. The x is not there, so you're not going to use your change of base. Okay? You're simply going to apply linear properties. It's not a power. Well, first off, you got to find out what 10 to the -2nd power is. Now you can caret it for now. It'd be 0.01. Now the reason why you got 0.01 is because, remember, to make a negative exponent a positive, you would put a 1 over it, and then 10 and make it positive, and that'd be 1/100th. Well, that as a decimal is 0.01. Linear properties is in when I just get rid of times 5 with division by 5. And that's all we do. Okay. 0.01 divided by 5 is 0.002. There's your answer. 2/1000ths. Okay, log base is 10. First off, get rid of the log. Remember, this is the base and this is the power. So it's 10 to the first power. Okay, you can put the caret there. Yeah, put the caret there. 10 to the first power equals the expression 4x. So I'm solving for x. X is not in the power now, so it is not a power. It's just x to the first power. So I'm applying linear properties. So you need to find out what the heck 10 to the first power is, which is 10, and then 4x. Now, get rid of the times 4 with the divide by 4. Linear properties means you just get the x by itself through inverse operations. Okay, next one. Base is 4, the power is 3. So we have 4 to the power of 3, and then 5x on the other side. Now I need to solve for x, that's true, but x is not within the power. See, the power is 3. X is not a power here, okay? It's just 5x. So we just apply good old-fashioned linear properties. Now you're going to need to raise 4 to the third power, which is 64, to find out what value's over there. And then you divide by 5, and that's going to be 12.8. Okay. Okay, next problem, change that 243 to a 6, please. Now, before you can get it out of log form, if the log has a coefficient in front, you need to first divide each side by that 3, because that means times 3, and you divide your 6 by 3. So before you can convert it into an exponent form, okay, you're going to need to do something. Now you're good to go. Base is 3. The power is 2. Okay, this is going to be an easy one. So 3 to the 2 power equals x. Well, 3 to the second power is 9, so 9 would equal x. Easy enough. Back page. Whatever number was there, make it a 2. I have this page all messed up. That goes from put a 2 there. Now you have 2 logs. Now we need bases, they both be to base 10, so you need to use the properties of logarithms then, okay, to condense it. So you write log base 10 one time, put a parentheses after it, and you will be putting x, and it's minus, so you'll be putting divided by 3. If it was a plus sign, you would put times 3, and then you put your equals 2, and now we're ready to roll. So 10 is the base, 2 is the power. So we're going to have 10 to the second power equals the expression x divided by 3. So you're solving for x. X is not a power. It's just divided by 3, so I use linear properties. You have to figure out what the heck 10 to the second power is. It's 100. Now what's the opposite of, how do you get rid of a divide by 3? Well, you times 3, and that's 300, so 300 would be equal to x. Okay, next one, same deal on these next ones. You have multiple logarithms, so you need to condense it into one. So log base 10, 3x to the second, and then it's a minus, so that would be division by 3, okay? So, first, now get it out. Remember, 10's a base, 3 is the power. So you have a 10 to the third power. Now, I want you to simplify this. This can be simplified. What's 3 divided by 3? Now, you're still going to have the x to the second here. 3 divided by 3 is 1, okay? You can put a 1 if you want. You really don't need a 1 in front. If it was a 2, I'd put it there, but the 1 we don't need, okay? Now, again, x is not a power, but it is to the second power, so there will be 2 answers here, okay? Some of you are like, oh boy, no, it's not going to be one of those. 10 caret 3 is a 1,000. Now, there are 2 answers, but x second is all you have. You don't have an x with it, okay? So you're going to still use linear properties. You are not going to use your factoring properties. Don't need to, because you don't have an x with the x second. It's just x second. You just delete the power and make a root of a 2. Okay? So 2 second caret 1,000. And I got 31.62. It could be positive or it could be negative, because it's an even root. Okay? So here, I'll show my work here. So its even root would be the positive or negative value of 31.62. Okay, next problem. Log base 10 of 6x squared minus log base 10 of x equals 2. Okay, so first off, you got to condense it down to a single logarithm. So you're going to have 6x second, minus would mean divided by x. Okay, so let's get it out of log form. This is the base and this is the power. So on this side of the equation, we're going to write 10 to the second power. Now simplify that. You know, x second divided by x is x, and then you just, the 6 would just remain. Okay? So 10 to the second power is 100, 6x. Now, x is not a power again, and it's just to the first power. There's no power on it. That means there's going to be one answer, and we just apply linear properties. So you just get rid of the times 6 with a divide by 6. You can write 16.66 or 67 if you want to go second. If you want that to be a better answer, you can go just put 16, or you can put 16 and 2/3. Doesn't really matter. Okay, or 6 repeating is fine too. Okay, last problem. Log base 10 of 8x to the second minus log base 10 of 4x equals 2. Okay, again, switch those numbers. I have the wrong number. Okay, so first let's get it down to a single logarithm. It's minus again, so we're going to have the 8x to the second divided by the 4x. Okay, equals 2. Now, base, power. So then we'd have 10 to the power of 2. Now simple, 8 divided by 4 is 2. X squared divided by x is x. Okay? So, solving for x, it is not a power. It doesn't have a power on it, so that means there's just one answer, and we use the linear properties to solve it. First off, before you divide by 2, you got to figure out what 10 to the second is. That would be 100. And 100 divided by 2 is 50, so 50 is equal to x. Okay. All right, I think we're good. Remember, there's a number 13 on the back. Please do it. Okay.